Hello guy. In this section we introduce you guys how to just conduct for the multiple regression model analysis, including for two parts. The first part we'll talk about how you do it for the correlation analysis, and another part we do it running for the multiple regression based on the simple regression model that we already learned in the previous section. So with this one, I will recommend you guys to just use for the example about the programmer salary surveys of the companies, and the data will be available. I will show you later. But we take a look into the business context of the data first. So the software firm collected data from a sample of the 20 computer programmers, the guys who make a lot of money, right? A suggestion will make that the regression analysis could be used to determine if the salary is related to the year of experience. That means the experience of the employee and the score of the firm programmer aptitude test. So the same like if you score it very high in the aptitude test, that means you get very good aptitude in terms of the computer programming, and you should be paid higher, right? So that's really makes sense. And the years of experience, the scope aptitude test and the corresponding annual salaries had been sampled of the 20 programmers. So in the next slide, so the data is be look like this one, and also in the end of this one I already just including also for a categorical independent variable. So with this previous example, we make the extension of the problem involving for the computer programming that we mentioned before, right? But however, they want to just clarify about believe that annual salary also related to whether an individual have the graduate degrees in computer science or information system. A graduate degree that means a postgraduate degree, master degree, or PhD degree, a doctoral degrees in the computer science or information system. And if that one have the degrees, they will say yes. That means they have the master degree or PhD degrees. They will say no if they don't, and yes if they say yes. And they collect the data. So basically, all the data has been uploaded in the file called the salaries, and you can easily download it from the book, from the website Canvas. However, I open it over here already, and this is what we going to just have it. Okay, so of course, like I will just copy it into the new one, and this is the experience. This is the experience in year, and the test score. That means the aptitudes about the expertise, and also the decrease will be yes equal to no, right? If that should be no, that means I will say 0. If yes that's out, that means that should be yes. That means that one have a graduate degree. So they say yes, and that means 1. So this is just an if function, very simple one. You can easily do it. And lastly, I have the salary data over here. Okay, the thing will be like I will want to cut this one, and I want to just set it over here. Okay, whatever this could be, but I want to make sure that's because the degree now with yes or no is no longer important to me. So you can easily find that is with this one. I have some kinds of information, previous information about this. The data sets includes 20 observation, right? Observation. Okay, in which we have 4 variable, right? We have 4 variable, including for 3 quantitative variable, that's including the experience, the test score, right? And last one will be salary. Okay, so they could be the quantitative variable, while the other one qualitative variable or categorical variable. That's one will be the degree, right? Degree. Okay. All right. So now think about in the case that what we exactly wanted to go to see. We want to see what could be the experience, right? We have the experience, we have the test score, we have the degree, and we have the salary. We want to see, like, for experience, for example, the first guy, he have a 4 year experience, and he last time when he take for the test of the expertise, he got about 78, and he don't have the degree for graduate degrees, so he have 24. He make it like about 24 $1,000 in those years. All right. Okay. Why the other one? For example, this one, right? He have about up to 10 years of experience, and he have a 84 degree point in the last exam, and he had a kind of graduate degree, and he make it like $38,000. This guy, he has 7 years experience, only less than this guy, but he make very high in the test score, and he had the graduate degrees, and he make it very high. I think that should be almost highest, $43,000 compared to the rest of all the employee. So that give me some kinds of like first kind of expression, right, about the data. So it looked like some guy, they are trying to use for the experience, the test score, and lastly will be the degrees. Okay, to explain for the salary. Okay, to explain for the salaries, and the salary here would be something like this. Okay, and we want to see like if the experience has the impact into salary. That makes sense, right? The more experience, the more years of experience you have, the higher salary it should be. Yeah, that makes sense a lot. Another one would be the test score. So the better test score you can make in the exam, that means you have a better expertise in programming, and you should have a better payment. And decrease. I hope so. So like if I have the decrease, I will get better payment than the one who don't have it. So because I have a kind of official and academic training, it not necessarily mean that I will have the higher payment, but it normally it will be. So that will be the thing I want to do. So what first of all, we're going to just do with the correlation analysis, right? Okay. I want to change everything into Tom Roman, so it's make more with me like more comfortable. So with the correlation analysis, we have two ways to do it. Remember, the first way is should be the scatter plot. Okay, for the scatter plot, you can do it with the scatter plot with the two quantitative variables. So first of all, I want to see the relationship between salaries and the experience. They both will be the I'm sorry, the quantitative variable. So first I select for the salaries. Okay. Second I select for with the control function. Remember that I will hold the control function key with the control, and then I select for another one. So I now at the same time I select twice two of the column. I go into insert. I go into the scatter. You can see over here, right, the scatter plot between them two, and you can see like it look like the data, so that oh, of course, like I can add in for the asset title. So for this title, this side I would say this would be experience. Okay, and this side I would say this would be the salary. Okay, I would say correlation between salary and experience. Okay, and it looked like with this one, I see that there has like an upward slope, kind of positive relationship between salary and experience. That means the higher experience, the higher salary, and that I can make, and I can confirm it one more time by right click, and then I add for the trend line. This can create it by this way, right? Create for me for the linear regression. Okay, and it showed me for the trend line going up. That means it could be a positive relationship. Okay, another way that I can do it too, does be the I will not just create for the scatter plot only, but I can at the same time create for the numerical analysis of correlation, right? So with this one, I can do it with two different number. The first number would be, remember, the covariant, right? Covariant. So with the covariant, I would just use for the covariant dot s, because this could be the sample, right? So I select for the salary, and another arrays could be the experience, and I want to see it. Okay, so that could be a positive number, and correlation coefficient. Correlation coefficient, I will use the function correl. Okay, and it was the same time I select for the salaries, and at the same time I select for the experience for two array, and I compare them, and it looked like this could be a positive one and close to positive one. Okay, so with this one, with the scatter plot, with the covariant, with the correlation coefficient, I all can say that they are positive relationship between what, man? Between salary and experience. Okay. Okay. Experience. Okay. Yeah, and the same thing that I can do like that. I can go and collect it, and I can just do it with the analysis at the same way between another collect pairs of the salaries, and also for the test score, right? The test score. Okay, and I do it for the scatter plot. I do it the same, so I do it very quick for you to see. Alright, and over here you can easily see that the scatter plot will look like this. However, even when they will be kind of like sum in the sum cluster, it's not so clear for me to see the relationship between them. It's not because of the data, it doesn't tell me anything. But however, the view of it about the kind of empty space has just limit my visualization. You can see, for example, I can add in for the acid title, right? For this side, this should be the test score. Okay, because the test score has been scored spread from like 60 something into 100, so that's all the thing I have it here. Another side, this one of course let's be salary. Okay, and I would say this could be the correlation between salary and test score. Okay, okay, that's the point. Alright, and because it's there too much like the space over here, I want to just clean it. So from 0 into 120, actually from 0 into 60, that should be empty space, and that's way of space. So I try to just format as, and I will skip it, not just start from 0 but from like 60, and you look like this way. The data now spread in a right order. The same thing applies for the salary for the vertical axis. So from 0 to 50, but actually I don't use the space from like 0 to 20, so I will clean them out. Do the same format axis and start from 20. Okay, look better now, right? And of course you can add in for the trend line, right? You can use the linear, and you see it that should be going up, so that should be positive relationship. You check also for the correlation, so I can do it with the covariant dot s, right, with between salaries and the test score. Okay, right, and you can see that this should be a positive number, positive relationship. Corral for the correlation analysis, salaries, and one more time will be the test score. That could be larger than 0, but however it's not larger than 0.7 or 0.8, so it's not so close to 0, sorry, for to positive 1. So I just can say like the positive relationship between salary, this not salary, but the salary and the test score. Okay, and this is a strongly positive relationship. Right, the last one, between decrease and salaries. You can actually just review it or decrease like this, yes or no, and salary or not. We can do it with a couple. How we gonna do it? We can create, go and insert, and actually, yep, I do it with this one, the cluster column. Okay, we would do it like that way, but however at the same time, come back over here, you can do it with the it's not histogram, it's not the combo, but you will go and just go with the pivot chart and pivot table, and you can go over here, select for the data already, assisting worksheet, and go up here with the decrease. That should be a categorical variable, and salaries, that should be a kind of quantitative variable, right? So I want to just put the data over here. Okay, yeah, sorry, I will have to select them all, the data like this. Okay, and I do it right now. Okay, this is the graph, and this could be the pivot table. So I put for the axis, that's be yes or no. For the decrease, I want to put the yes, go up, move up a little bit. This look like much better now. And then I put in for the values, but not for the sum of values. I want to change them into the average. Okay, so I can see the average income of the people who had a graduate decrease. Okay, so I can say and change for the name would be like what it would be, the average income, average salaries or something, salaries compare by whether an individual has a graduate decrease. Okay, so with the guy who have a say would be like of scholar, I can change it to into whatever I want to say, I want to do. So which one would be look better? I still cannot see the one that I really so feel comfortable with. So I will put the data level, so you can easily see it over here. Okay, however, that's easily to see that the average salaries compared by two of them with the frequency table. We can see that easily say like the yes people, that means the people who have the graduate degree, they have the better and higher salary compared to the people say no. So that means we can say like, yeah, it looked like in comparison in general the people who have the graduate degree earn higher. Okay, but however, that's all will be the correlation analysis, and we just do it with the first impression based on the data visualization. Now let's continue with the model. Okay, so let's go into and do for the regression analysis. Okay, and to do for the regression analysis, I will try to answer for the three questions first. Okay, the first question would be what the model tell. Okay, what the model tell. Second question, how is the model Reside fits to the data? Okay, and the last one, how is the model statistically significant? Okay, to do that, I will go and just run for the regression analysis, and this will be the time for to go into for the data analysis bottom that we already learned about. One more time, if you don't have that, you can go into option, go into add-in, go into Excel add-in and go and select for the analysis toolbar, analysis VBA and solver add-in, and click OK. With me, I already have it, so I don't want to install it anymore. But if you don't have it, just click on OK, and then just run for about a minute, but just less than a minute, and the package will be installed into your computer. But that's the time for me to go for the data analysis tool analysis. So I go and click on, and I select for the first of all, I can do for the correlation one. Remember, so what is the correlation? This will be the time for us to go and gonna check for the relationship between so to do that, with me it's a little bit different. So with me, when I run for to do that, so it a little bit different. So I will have to go and insert and copy for that one, and this will be should be all the things like about the variant or the quantitative variable, right? And I'm going to do it for, so first of all I will just not run it yet, but I will go and just go for the highlight multi-collinearity check. Okay, and I want to check for the multicollinearity problem. So if the multicollinearity problem could be has happened, so that's could be get a big trouble. But we need to test for the significance for multicollinearity. If the independent variable have a highly correlated when the correlation coefficient are higher than 0.7, that could be has some problem. Okay, this will be going to have the problem between the dependent variable, and should be the time for us to be very careful about. So I would say like we going to do it and do analysis for the quantitative variable in the model, and go for the correlation and click OK, and you input for the data. Okay, label in the first round to just make it understand that the first round will not just the data but just the name of the variable, and you want to output ran right over here. I want to see it right over here, and let's click on OK, and this will be the time for it to just read it. And in like another program, especially for like SPSS and other kinds of statistical tool, they will clarify very clear about that one. But however, it is very easy to understand. For example, is variant for the column and salary for the row. The intersection could be 0.855. This will be the correlation here. They totally the same, right? If you take a look, and you will see that they are totally the same. And that will be the same, right? This one will be the correlation between salary and experience. And you see, experience, salary, yeah, very true. That's the correlation coefficient between experience and salary. And the same would look like this. Okay, so you can see it over here. Test score and salary intersect would be the relationship between salary and test score, and this would be look like this. The only thing that I want you to be go to check, because as we have there two quantitative independent variables, that should be the test score and experience, right? And they will be test score and experience, and they should have the they have a positive relationship between them. This is correlation coefficient between them. But however, the good thing would be like they smaller than 0.7, so that means they have positive relationship, but don't have the side that they really have a strong correlation, and that's good. That means the model is good to use. Okay, and next time you can go and check it on like SPSS or something like that, right? Okay, now the regression analysis, when we already sure that don't have the problem about the, so because the correlation coefficient sorry, between independent variable have a or between minus 0.7 and 0.7, that means small, around 0. So we don't have the model, the data doesn't solve the problem of multiculinarity. Okay, that should be the point. So now let's go for the regression analysis. One more time, we're going to for the data analysis, and we scroll down for the regression. We click OK. Input for the Y rand. Remember, the salary will be the Y, right? So Y will be the salary. Okay. Oh, one more thing. So because that I already tell you, you will be have to make sure that all the data will be just save it properly, and the salaries at the all the kind of independent variable, they must be close to each other. Why the Y, that means the dependent variable, they be separated. So we go and do for either analysis. The Y rand, that should be fine. Salaries, right? That's very clear. But however, for the input X rand, all this variance, test score, and decrease, three independent variable, they may be close to each other. Okay, label for the first round, output rand over here. Okay, and yep, that's everything. And you can click on OK. Yep, this could be the result of the regression model. Actually, we don't really need this one. You can clear it, or you can take a look later. The sum of the variable, sum of the number that we really have to care about will be, first of all, this one, adjusted elsewhere. Another one will be the F statistic and the p-value of S. Okay, F test. Okay, so this both very careful. Another one, coefficient, and the last one, t statistic and the p-value of t statistic. That could be everything we really have to answer it based on. So first of all, we're going to just answer for all the questions separately. First, the model. Okay, what is the model tell? What the model tell? So first of all, we want to just write now the regression model. Remember about the model, it could be what it look like. So if that's really the data, so the data will be something look like this. Sorry guys, yep, the data itself should be something look like this, right? So this would be the model. The model between 3 is variance, test score decrease, that have the impact into the salary. So Y here, that should be actually the salary. Y the other, beta 1 time for x1, x1 should be what? The salary, sorry, this bit. And x2 should be time for the test score, and x3 it should be time for the degree. Okay, alright, and now this will be the time for us to write out for the regression model. So based on the result and the coefficient, we will put it on all. Okay, so first of all, remember this could be the intersection. So salary will equal to intersection. That should be the first one, 7.94. I would just put it like 94. That's fine. Then plot for the coefficient associated with the experience variable. So coefficient will be 1.45, something like 1.15, sorry, 1.147. So I will put 1.15 and time for the experience. Okay, plot for the test score, 1.96, so this is 20. Okay, and we just round it up, and time for test score, and finally plot for 2.28, time for the degree. Okay, right. So this could be how it looked like. I will just move it a little bit. No, what I have to do is stupid. Just move it up a little bit. Okay. Now I have the graph of the regression model. So this would be the time for just interpret the regression coefficient of the model. Okay, so what does it mean when we say beta 1, beta 0 here? That would mean 7.94. What does it mean? This means when all other independent variable equal to 0. Doesn't mean they don't have the experience, right? Here does mean no experience, no test score, the test score is 0, and no degrees. The guy will make 7.94 unit. Here that should be $7,940. Okay, in average. Right. When all the other independent variable they don't have anything, 0, 0, 0 point here, you put it at a 0, 0, 0. That means the salary, that cell will be just equal to 7.94, and that means that guy will make $7,940 in average. Okay, beta 1 that's equal to what here? 1.15. That means what? When the experience increase for 1 unit, that means 1 year, okay, of experience. Does one have a 1 more year of experience? Okay, their salaries will increase for 1.45 units in average, on average, or you can say on average. That means $1,150. Remember about the units of the salary could be $1,000. So that means 115. That means $1,150. Okay, when other variable is stay, it kept constant. Okay, constantly. And last one, no, sorry, beta 2 equal to okay, I will change it, copy it, and the last one, the beta 2 here, this means 0.20. That means the experience when the test score, right, the test score increase for 1 unit, 1 year. No, that should be 1 point in the exam. Okay, the salary will increase for just $0.20 unit in average. So that means $200 when other variable keep constant. And last one, this is a little bit different because this degree could be a pause. Sorry, that should be pay the 3 equal to sorry 228, with a categorical variable, that's a little bit different. That means when I will change it a little bit. When decrease equal to 0, okay, the salary will be equal to what? 7.94 plus 4. Yeah, I will just change it a little bit. I will just copy it. Copy all this one, okay, and you see what will be the difference. Salary will equal to this is variance test score, and the decrease now is equal to 0, right? So this could be one more time equal to all the thing like that, but with the rest will be there for 2.28. That should be mean 0. So they just cell terminated is other. Okay, but when the salary decrease equal to 1, that means the guy has a graduate decrease. Okay, then the model will be changed. The model will change itself. The model will change itself, and with the decrease time for decrease will be equal to 1, right? And that's mean, one more time, the salary will be equal to that's 1, but for decrease will be equal to 1. So that's mean here, and you can see it over here. The two salary function, they're totally the same, but they're different for the second one when decrease 1. That means they are 2 plus for 2.28, when the other that should be have no. So what it mean here? So that mean the guy who has graduate decrease can make 2.28 unit higher on average compared to the one who don't. Okay, and of course 2.28 unit, that means $2,028,000. Okay, so that means the guy who have a graduate degree, they can normally make it's about like $2,280 dollar more than one who don't have that one. Okay, so that's the meaning of all the regression coefficient in the model. Now let's go into the second question. How does the model result fit it to the data? So for this one, that means we answer for the third question. The goodness of fit of the model. Okay, so that means we check it for the adjusted or sway over here, and that's the reason why I just go it up here, right forward. When you see like this, you can easily change it into percentage, and that should be easier to interpret. And this means the model could explain 81.81% the variation or variation, whatever, of the here the model will answer the salary, right, of the salary. Okay, the variation of the salary, and that's mean in comparison, that's been 18.19% of the variation of the salary has not been explained by the model yet. That means adding more relevant variable will help to improve it. Okay, that's the point. The third question, how the model statistical significant? We can go and answer it for how the whole model work. Okay, how does the whole model work? And to answer this, how does the whole model work? To answer this, you're gonna just check it with the F statistic, okay, F test, and if the p-value of the F statistic is smaller than 0.5, that means the model is okay, good to you, right? Actually, we have the three threshold with the people normally call the significant level. Significant level. If you remember, significant level, and we have the correspondingly, that should be the confidence level. Okay, so if the significant level we have a 0.1, 0.5, and 0.1, okay, and confidence level in like corresponding, that should be 99%. That means 99% I'm confident that my assessment will be correct. 95% and 90%, of course. Okay, let's just go and up over here. Let's check it. So we need to take a look into the F statistic and especially the p-value of F test. And if you see this one is kind of a scientific number that you cannot understand, just change it and make it become a normal variable, comma style, and you see it's very small. Okay, so because the p-values of F test is 0.00, that means smaller than 0.05, the model is significant. That means the model is good to you. And if you want to take the look why it should be, just recommend you guys to just take a look into the significant test of the model. Okay. However, I will not just spend too much time on that one. Alright, and last one I can answer for another question, E. That means how the each individual variable is work. Okay. Alright, now let's check it. So first of all, let's go and check it for the p statistic. Actually, we don't really have to care about the coefficient of the intercept, but we need to test about the experience, about test score, and about the decrease. And if we want to do it, we have to check it for the t-test. Okay, and if the p-value of the t-test for each individual is smaller than 0.5, that means the variable is good. If not, or otherwise the variable is not good, should be excluded from the model. Okay, now let's go and check it. So we're gonna just see like the p-values, because the p-values of the what this one here is Biren. Now p-value of t-test, alright, t-test of Isbarian, the variable Isbarian is equal to 0.001. That's smaller than 0.5. So that means Isbarian is or represent a significant, statistically significant relationship to salary, right? you can go and gonna check it for the another one. That should be the test score. And good here, the t statistic could be a little bit high, 2.19, and the p-value is 0.04. The same, right? This is smaller than 0.5, and this one smaller than 0.5. So I can apply the same. So the p-values up here not superior anymore, but the test score, okay, is equal to 0.04 to 3, okay, smaller than this, and we can say the test score represents statistical relationship to salary. Last one, check it. Decrease even when it had the positive correlation coefficient. The coefficient in the regression model. The statistic is not so high, and the p-value is larger than 0.5, and even it's larger than 0.110%. So that means it's bad. That means we can go over here, and the t statistic piece of the decrease is around 2.20, what? 26.8, right? That's larger than 0. Even like 1. Okay, so that means here the decrease do not represent a insignificant, statistically insignificant relationship to salaries, and that means this one should be eliminated from the model. So with me, when I gonna check it and I see like no, decrease, it should not be here, right? It should not be here. Just the experience and test score has a significant level into the salary. And this is how I go and run for the multiple regression analysis, from the correlation analysis to the multiculinarity check, and finally the regression analysis. Thank you so much for your listening.